Hello everyone, this is Brendan. It's going to be a short video about periodic trends. It's going to be a very brief introduction. It's going to explain the basics of Z effective, atomic radius, ionic radius, electronegativity, electron affinity, and ionization energy. If a student already feels like they know the definitions of these terms, please skip this video and continue to the next one. If you're unfamiliar with it, maybe you weren't catching it in class fully, feel free to pause the video as I go, copy the notes, and then listen to the explanation. I think you're going to get the most out of the video if you do that. So the first concept I'd like to talk about is effective nuclear charge. And what the effective nuclear charge is it's basically just how much of that nucleus, how much of the positive charge coming from the protons in the center is actually able to make it to the outermost electrons. There's this concept of inner electrons that create shielding. So some of those positive charges from the center can't really make it all the way out to the valence electrons because some of them are kind of blocked by the other ones. So that's the basics of effective nuclear charge. I'm going to get into it a little bit more in the next series of videos, but remains relatively stable going down a group, and it increases as you go from left to right across a period. Next is atomic radius, and the atomic radius is loosely defined as the mean distance between the nucleus of an atom and the electron cloud. Saw that I had a quick typo there, just fixed it. And the general trend for atomic radius is that it decreases from left to right across this row. It actually gets smaller as you go to the right, and it increases from top to bottom. So the largest atoms are going to be found near the bottom left of the periodic table, so around the Francium area. Next concept is ionic radius. So just like atomic radius, ionic radius is really the same thing. It's just a measure of the distance from the nucleus to the outermost electron. However, with ionic radius, you actually have atoms having different numbers of electrons. So when they're in their ionic state, as we know from earlier in chemistry, atoms like to get to that noble gas configuration. So metals give away electrons to gain a positive charge, and nonmetals generally accept electrons to gain a negative charge. Most of the test questions that you're going to see focus on ions that are what we call isoelectronic. Iso is a prefix. I don't know if it's Latin or Greek, but it means same. So isoelectronic just means the same number of electrons. Might be something like, Na plus, which has lost an electron, and F minus, which has gained an electron. So they both have 10 electrons at that point. Again, more examples are to come. Next concept I want to talk about is electronegativity. It's formally defined as the measure of a bonding atom to attract electrons. The way that I like to think of it and generally like to explain it to students is think of two atoms when they share electrons. Think of them as almost never sharing them equally. One is always kind of bigger and stronger and wants to take more of those electrons. So, best example I think of brothers playing video games. If two brothers are of different ages, maybe one is 12 and one is 8. Well, I know how I am with my brothers. I'm the big brother. I played video games a lot more than they did. I would not share. Those games were mine. I was going to win, and I was going to play it first. So think of electronegativity in that manner. You know, the more electronegative atom, just like the older brother, is going to hog the electrons in the same way that the older brother hogs the video games. On the other hand, if you have two twins, maybe you have twin brothers that are identical in every way, they're going to be able to share those. They're going to be equal in strength, equal in wit, equal in their cunning, and for those reasons, they're probably going to share the video games. They're playing equal amount between the two of them. In the same way, if two atoms are the same, they're probably going to share those electrons. There's other factors that come into that. We'll explore it more deeply shortly. Next concept is electron affinity. Electron affinity is defined as the change in energy when an electron is added to a neutral atom to form a negative ion. So, what do we think of that generally adds electrons? Well, those halogens, that group 7A, fluorine, bromine, chlorine, iodine, those like to grab electrons because they want to gain an extra one to become like noble gases. And that kind of makes sense. That's why they have a higher electron affinity, is because by just accepting a single electron, they become like the noble gases which they desire to be. And the final concept I'll talk about in this video is ionization energy. So ionization energy is defined as the amount of energy required to remove an electron from the valence shell of a gaseous atom. So basically, how hard is it for me to pluck that valence electron off, to just completely remove it, just get it off that atom? And it follows the same pattern as electronegativity. It increases from left to right across a period, and it decreases as you go down a group. So, following these trends, fluorine would probably be the hardest atom to try to pluck an electron off. Please join me for the next videos as I give some more concrete examples and really try to provide you with more visuals to show you how exactly this works.